Alright, this first section of Chapter 1 talks about lines. The first thing you need to remember about lines would be the slope. The letter that represents a line is M, and the slope represents rise over run. It can also be change in y over a change in x. And we also will look at it as y2 minus y1 and x2 minus x1, where the x and y values are the coordinates of some points. The order of these does not matter. You could put y1 minus y2 as long as you put x1 minus x2. Alright, for these two coordinates, 4418 and 3248, to find the slope, you would take the y values, 18 minus 48, over the x values of 44 minus 32. Now that would be a negative 30 over 12, which you can simplify to a negative 5/2. And you could also write that as a negative 2.5. But usually for the purpose of anything you're going to do with lines, you are going to want to leave it as a fraction, not a mixed number. Now when dealing with the slopes of lines, if a line is horizontal, then our slope is 0. And if you were trying to calculate it using some coordinates, you would have a value of 0 on the top and some other number here. Which means that in order to get 0 in the numerator, your y values must be the same. If our line is vertical, then we have a line where the slope is undefined. And in that case, you would have some value over 0. And our x values would be the same. Now then, once you have a slope of a line, you can figure out the equation for it. There are different ways that an equation can be written, and we'll still use the points 44, 18, and 32, 48. First way an equation can be written is in slope-intercept form. Slope-intercept form is y equals mx plus b. We know that m is the slope, which is a negative 5/2. Our b value is the y-intercept, where it crosses the y-axis. That we are going to have to calculate using one of our two coordinates. And for this one, we will use this one, 44, 18. 18 is our y value, 44 is our x value, so we substitute those in for x and y and come up with the equation of 18 equals a negative 5/2 times 44 plus b. Okay, distributing the negative 5/2 to the 44, or actually just multiplying them, would get you a negative 110 plus b equals 18. And then moving that to the other side, we would add 110. And b would equal 128. And so then our equation would become y equals negative 5/2 x plus 128. Again, this is your slope, which tells you the rise over run. It says that it goes up 5 and over 2, and since it's negative, our slope would be like that. It crosses the y-axis at 128. That's slope-intercept form. Second type of a line that you can write, or second type of an equation that you could use, would be the point-slope form. In point-slope form, our equation is a little bit different. It has y minus y1 equals m times x minus x1. The x1 and the y1 are a coordinate that you know. The x and the y stay as x and y. So still using these two, we know our slope is a negative 5/2. And this time we are going to use 32 and 48. And so we would have x minus 32. And on this side we would have y minus 48. Now if we wanted to convert that to slope-intercept form, we would then have to distribute and get a negative 5/2 x plus 80. And finally add 48. And come up with the same equation. A third way that you will see equations written for lines would be general or standard form. General or standard form either puts it as ax plus by equals c, or ax plus by minus c equals 0. Difference between the two is you get everything to one side with this one. And typically, or usually, your values for a, b, and c in either form are going to be whole numbers. So using our equation that we know already, these 2 points, we know we have an equation of y equals a negative 5 halves x plus 128. So if we bring the x value to the other side, it becomes a positive 5 halves x plus y equals 128. And getting this to be a whole number, we would multiply the whole entire equation by 2 to get a final answer of 5x plus 2y equals 256. Or in this case, it would be 5x plus 2y minus 256 equals 0. And I'll let you look up the difference between general and standard form. Finally, for lines, we can have them be dealing with 2 lines. They can be parallel to each other. And with parallel lines, they have the same slope. So if we were using our original equation for our line, which was a negative 5 halves x plus 128, if we want to be parallel through the point 8, 3, you're going to need to use these 2 coordinates and our slope to figure out our new line, because it's not going to go through the same y-intercept. And again, you can use point slope form or slope intercept form. For parallel lines, we'll use point slope form. It doesn't matter, but we're just going to do it this way so that you see how to use it again. So we would have y minus 3 would equal a negative 5 halves times x minus 8. Distributing the negative 5 halves would give us y minus 3 equals a negative 5 halves x plus 20. And finally, moving the 3 to the other side by adding it, our parallel line would then have an equation of y equals negative 5 halves x plus 23. And if we have parallel lines, then we can also have perpendicular lines. Perpendicular lines the slopes are opposite reciprocals of each other. So, for example, if we had the slope of a line being a half, the perpendicular line would be a negative 2. Again, using our line that we had before, y equals a negative 5 halves x plus 128. The slope of our perpendicular line is going to be a positive 2/5. And so if we were going to go through the point 83 again, this time we'll use a slope-intercept form. We would have 3 equals 2/5 times 8 plus b. Distributing the 2/5 would get you 3 equals 16/5 plus b. Then subtracting 16/5 from both sides. And b would equal a negative 1/5. Because 16/5 is 3 1/5 of the negative variety. And so then our final equation for the perpendicular line would be y equals 2/5 x minus 1/5. And there's everything from section 1.